Hello everyone, this is Sita Kumari and I'm very grateful to Professor Kabir for his constant guidance and academic support. Today I'm going to talk about chemical bond and its types. So these are the contents that we are going to have a look. So almost everything we see and touch in our daily life is a result of a chemical bond. The air we breathe, the food we eat, the clothes we wear, and so forth, all made of one or more chemical bonds. The force which holds together the particles, atoms, ions, or molecule in a chemical species is known as chemical bond. As we can see how the ions are bonded together here and how these electrons are sharing. They're sharing to each other, right? This is anion bond. The bonding, which results due to the complete transfer of valence electron between atoms, is called anion bond. Here we can see how sodium is transferring its valence electron to chlorine and making its own stability. Like it has 281, and it's becoming 28. Like the 8 is stable. It's completing its octet. And here, in terms of chlorine atom, it's becoming an ion because it receives or accepts one negative charge here, and it was 7287, right? And 7 becomes 8 when it has been added to another electron. It becomes 8. It completes its octet. So this is known as anion. This is known as cation. Here we can see magnesium has 282, right? And it transfer or it yeah, the transfer of two valence electrons makes it two positively charged cation, and chlorine becomes anion, and this together makes magnesium chloride. Here in calcium oxide, it makes calcium, calcium becomes positive charged cation, and then oxygen becomes negative, right? Because it has 6 and it receives 2, so it becomes an ion, and together they form called calcium oxide. What is covalent bond? Covalent bond is more about sharing of electrons. A covalent chemical bond results from the sharing of electrons between two atoms with similar electronegativities. But here we can see, as we know, the atoms make or molecules make their own stable or complete their octet, right? They must have 8 electrons in their valence electrons, and this is how they make their compounds, or they make their own stability, right? But which is like hydrogen is exception one, where it makes it two plate, right? This because it has one electron, right? So it's sharing its own, and this is sharing its own, and they share and they make their two plate, not octet, right? So this is since they have same electronegativity, and they are sharing their electrons, their valence electrons. This is known as two plate, and this is also called nonpolar covalent bonds. So nonpolar means when two atoms have same uh, electronegativities. Let's have example of polar covalent bond. So polar means the atoms have two or three, whatever atoms, they have uh, different electronegativities. Like oxygen has more electronegativity than carbon. So the double bond is formed when two atoms share two pair of electrons with each other. Like in carbon dioxide, uh, oxygen is more electronegative than carbon. So the electron transfer between two atoms is more electronegative than And in case, so in carbon dioxide, oxygen is more electronegative than carbon. So the electron present in the bond between carbon and oxygen would be pulled towards the oxygen atom. So so oxygen is more electronegative here, and um, I mean more electronegative than carbon. So the electron present in the bond between carbon and oxygen would be pulled towards the oxygen atom. So yeah, it's polar covalent bond. In case of hydrogen chloride, chlorine has higher electronegativity than hydrogen. So yeah, the chlorine would pull the hydrogen atom. So this is also an example of polar covalent bond. So this is metallic bond. So it means bond between metals. So when the metallic atoms comes closer, then it forms electron cloud, the sea cloud of electrons, and then they acquire a bunch of electrons. Here we can see these are delocalized electrons, and this is why they are the good conductor of electricity due to its metallic character. So as they close um, tightly, or they are packed very closely, right? And these are the examples of metallic bond, like in case of brass, copper and zinc bonded together. In bronze, copper and tin, stainless steel that we use in our kitchen, the glass plates, right? So these are iron, chromium and carbon combination. This is just a conclusion. Ionic bond, just transfer of electrons and making positive charged ions and make it the product. And then in terms of covalent bond, it makes non-polar if it's a sharing of equal electronegativities between atoms, and um, polar, right? This is non-polar, this is polar when there is a difference in electronegativities between atoms which are bonded together. So it's more about sharing of electrons. And in a metallic bonds, let's see electrons are here, and the bonds between atoms. This is just a conclusion which talks about ionic uh, transfer of electrons between non-metals and metallic, with the bond between metal elements in which electrons are delocalized. Yeah, and in covalent bond, the sharing pair of electrons. Thank you.